This one?
Yeah, the packet members.
All right, so we're on. Good to go. So hi everybody, welcome to the technical steering team meeting today. And for today's primary topic is for me to talk about some of the possible approaches for virtual networking, and specifically to discuss the one that we chose and provide a little bit of a progress update as to where we are. Just for clarity's standpoint, can you guys hear me okay?
Yeah, we can hear you.
Okay, good. I just wanted to make sure. Now, we normally have a standing agenda item for community acknowledgements and things like that. Is David in the room?
I am. Although I'll point out, I don't need to be the only one acknowledging. It would be great if this was a practice we all considered, but I'll throw it out there. And I didn't have a chance to update the wiki. I apologize. I'm waiting for a list of people who took part in last week's developer bootcamp event in China. I'm waiting for that list from Eva. When I get it, I'll post it. But I want to thank both everybody who participated in that. It was a really great group, and then everybody who helped organize it. It was a big effort from Huawei as well as Madan and I going, and so I thought it went really well. I mean to do a write-up and share more about it, but just at a high level, it went really well. There were about 30 people or so who learned a whole lot about ONOS and did some hacking, and I think there's now a good group of people going back to their organizations and their schools with knowledge about ONOS to share with their peers. So I think. Again, a good effort, and thank you to everybody who took part and helped organize it.
Perfect. Thank you very much, David. Okay, so with that, I think we can launch to the main topic here. I'm going to try to share my screen. 1 second. I'm fighting here a little bit with Chrome.
Luca, you missed your acknowledgement.
Really? Oh, I was just acknowledging everybody who organized and took part in the boot camp last week.
I saw this in the engineering room.
Yes.
Right.
So,
Oh, you were doing so.
a shout. We start every TST meeting with a community shout out for people who have done something really great over the last week. So thank you, thank you.
Thank you, everybody. To the right time.
Yeah, good timing.
Okay, finally here. Okay, so everybody should be able to see the nice psychedelic thing. And I just need to find my window now with the presentation. There it is. Okay, so let's talk about virtual networking in ONOS and specifically some of the rationale for the specific approach that we chose, as well as a number of other approaches. So there are some possible approaches when it comes to the virtual networking. Now, clearly, these are actually somewhat complementary and therefore not mutually exclusive. So one obvious solution is clearly to build OVX as a clustered solution, basically to harden the existing OVX, and so that it's not subject to single failure. And it would then become an OpenFlow-based network hypervisor, which would use OpenFlow to control network devices to the south, and conversely would expose OpenFlow controls on top of the virtual devices to the applications in the north. Now, in this scenario, just like with OVX, the virtual networks have prescribed topology, which are mapped onto the underlying network. And clearly, in the simplest form is a big switch, and in the most complex form, you can have an isomorphic mapping on the underlying topology. These networks are SDN networks, and they have no inherent connectivity, and any connectivity has to be programmed in form of OpenFlow forwarding rules. Now, of course, this approach allows various kinds of controllers to be able to manage the different virtual networks, because as long as you have a controller that knows how to speak of OpenFlow, you're good to go. So you can actually put ODL on this one, Floodlight here, and ONOS on another one. So that's certainly one approach, and I think this is probably at its root kind of the most flexible one when it comes to allowing control over the SDN virtual networks. But it also is narrow in a sense that it applies only to OpenFlow enabled networks. But one could argue that, why bother doing it anywhere else? So that's one approach. Another approach is the familiar edge overlay, which is kind of the Nicira OpenStack-like approach, where you basically are purely concerned with devices at the edge, primarily virtual switches, and you use basically VXLAN or NVGRE to act ingress traffic and let classical Fabric to manage everything else. Now, these networks have no topology, but conversely, they have implied connectivity, usually L2 and L3. Now, clearly, this approach works on top of either classic or SDN Fabric, but it's somewhat divorced from the type of fabric. It also produces classic networks in a sense that they're really not SDN networks, although some limited SDN programmability does exist at the edge, but it's very limited. And then this direction is actually currently pursued as part of the various OpenStack integrations, whether it be OPNFV or OpenStack. And so these are kind of two almost opposite spectrum type approaches. There's also another approach, and this is kind of what we started to work on in Drake, and that's basically take the core concepts of OVX and build them into a subsystem, as essentially build them as ONOS subsystem. This allows one to create networks, which are then realized by some logical tunnels, whether those tunnels are based on OpenFlow or some classic tunnels that's not prescribed. The virtual networks that are produced by this mechanism would have prescribed topology, again, similar like OVX. They don't have inherent connectivity, meaning that there is no data flowing unless you program flow rules. And consequently, it produces SDN networks. Now, one difference here is that rather than being programmable via standards such as OpenFlow, these networks would be programmable using high-level constructs, specifically either intents and possibly also flow objective APIs. Now, while this may not necessarily support, you could expose these networks to other controllers, but because they don't expose OpenFlow, you cannot just take any old controller. The controller would have to know how to program those networks using the REST APIs against ONOS. Now, this approach does support various on-platform as well as off-platform applications, but like I said, they have to be programmed using high-level constructs. And furthermore, on-platform applications, and I'll talk more about this later, there's a limitation in a sense that they cannot be tenant-specific. Means you cannot run an application on behalf of a specific tenant. However, you can run tenant-aware application, which is one instance of an application which is aware of tenants and can be performing different functions for different tenants. But it's still just one instance of the application. Yes.
Is that
What about echo? So is that due to the fact that Karaf doesn't allow us to run multiple instances of the same application, or because of some other limitation?
Well, so you could actually run multiple different components, multiple instances of the same component. It's certainly possible, and this is actually what the initial ODL incarnation tried to do, but it basically resulted in them having to redo most of the core lookup services and also created a lot of performance overhead because they had to basically channel the requests in weird ways. So, plus furthermore, our symmetric approach where we deploy an application that goes everywhere, the complexity, while possible, I would advise against that particular approach because the complexity would offset a lot of the benefits. So I don't think it would be. I think it's just basically a limitation of both Karaf and the approach that ONOS chooses to run tenant-specific apps. Besides, imagine running, let's say you have 10,000 tenants in the data center. Would you want to be running 10,000 different apps?
Well, you might, because each tenant might have a different set of apps that they want to run.
Yeah.
Yeah.
The question is whether you run those in the same JVM as the core, or whether you run them outside.
And so the question is, how do you, if ONOS were to provide virtualization, how you talk to the virtual networks is really the question.
Yeah. So the idea here is that if you want to, and I'll talk more about this topic later down the line. So maybe do you want to hold this? Is that all right?
Yeah, I mean,
Or not?
There's so many assumptions in these.
So where we left off was Bob was trying to make a comment.
Yeah, I was trying to make a comment, but there's so many assumptions in these first 3 slides. Like, I don't even know where to start. So you might as well just go on. But basically, I don't agree with any of this stuff. At least, or I have a completely different perspective on all of it. That, some of it I think is what I would have, come up with. But others is I think there are a lot of things that I think there are a lot of different perspectives one can take of it that are not represented in these first 3 slides. But I will say one thing, which is that the classic OVX seems a little bit like bare metal hypervisor kind of virtualization, and the overlay networks on top. Well, that's kind of that's just an application basically that could run on ONOS. That's pretty clear. And then this final thing is sort of an OS level virtualization, which is perhaps closer to containers, is a good way of thinking of it. And there's this big missing piece, which is OS level, full machine virtualization. That would be your OVX approach with an OpenFlow northbound. So I have a lot of other comments, but that's all I'm going to say for now.
No, that's basically what it is, right? I mean, of course, there is assumptions in here. I'm not sure how to actually go about it without making some assumptions. But these were, let's put it this way. Can I rephrase it? These were 3 obvious approaches that we could take.
Yeah.
And clearly, they're not mutually exclusive, right? So
the obvious fourth is to have an OpenFlow northbound, so have an integrated. No. That's so. First one is VMware. Second one is VPNs. Third is containers, but there's fourth is KVM, right? Which is integrated with the OVS, but it has a hardware northbound. In this case, it would be OpenFlow.
Sure.
So the difference is that unless this has an OpenFlow northbound, it's not like KVM. It's more like.
The first one that Thomas talked about had an OpenFlow northbound.
Yeah, but it was just OVX, not OVX plus ONOS.
It was OVX plus ONOS.
Oh well, there's a part that is just make distributed OVX, right?
Oh, just make distributed.
Yeah, and that's like your bare metal hypervisor versus KVM approach.
Yeah, so
which is a totally legit approach.
Yeah, which is like use ONOS as an application platform, build OVX in the distributed primitives using ONOS, using the distributed primitives of ONOS, but then running it as a separate process.
Well, that's more like KVM, but I think there are there's a whole spectrum of options, but I think you can.
Oh, absolutely. This is
OVX that doesn't have the full flavored features of ONOS, and is just has the distributed reliability.
That's what I'm saying. But let's let Thomas finish his presentation.
Yeah.
And then we can
start.
So you're absolutely right, Bob, in a sense that this is not a full spectrum of various options. These are kind of like the main strain, and then off of those you could build many different variants. So these were just kind of 3 main branches of directions that we could pursue. Okay, so basically around the break time frame, we decided that we would that potentially fairly useful, but also fairly practical approach might be to follow through with this built-in OVX approach. And one of the reasons is that ONOS currently manages networks which are not necessarily 100% OpenFlow based. You can discuss merits or caveats of this separately. That's, I think, a separate subject. But the whole idea was that if we wanted to provide virtual network mechanism on top of just OpenFlow and expose just OpenFlow, then I believe that the clustered OVX or variants thereof would be the right approach. But given the fact that a lot of the networks that we are actually dealing with are not necessarily 100% OpenFlow, and specifically also, even if they are OpenFlow, the different degrees to which they implement, the different devices implement various optional functionality and the pipeline differences, were going to present a significant challenge to exposing OpenFlow to the north. That was the reasoning. It's not impossible. It's just difficult. And so we chose this approach because it offered us to offer a high-level programming constraint.
I agree with using like some ONOS API to program the virtual networks, but I also like to say that, you know, if you're presenting a virtual network, you get to pick the pipeline that you present to, and if you get to pick the pipeline that each one of these virtual switches has, and therefore you can map that particular pipeline to the flow objectives one-to-one exactly, which would make things very easy, right? So programming you could expose a multi-table pipeline in every single switch, which would be the flow objective pipeline, and therefore then programming the actual data plane would become very, very simple. It would be very, very straightforward. So as much as I agree that using intent or flow objective API to program the virtual networks is probably a good starting point, I think providing an OpenFlow northbound connection is actually not that hard.
Okay.
Given the constraints that I just put out. Right?
I see.
I echo what Ali's saying, and I also want to say that the motivation you presented, Thomas, for me is not particularly compelling. I think there's something that, I guess what I find most appealing about the built-in approach is that you program the virtual networks using the ONOS abstraction. Like, that's the whole point of it, right?
Yeah.
Right. So, if we want to have different views of, I mean, it's not entirely clear what you mean by
that could be an application, right? So here's my point, right? If you build the built-in OVX approach, right, and you program using flow objectives or intents, you can build an application that exposes an OpenFlow.
Sure, that does OpenFlow to.
And then call it a day, right? Call it a day.
I agree.
Can I just say another thing? Let's let Thomas finish the slides.
Okay, sounds good.
We know what he's proposing. Otherwise, we have no idea.
Okay. So basically, during the Drake time frame, we've sketched out this last variant, and so this is sort of the general approach that we took. Okay. So some of the basic concepts are as follows. So a virtual network belongs to a tenant, and in order to avoid getting embroiled in tenant management, in ONOS we represented tenant using a very shallow representation. Basically, it's a mere tenant ID. Okay. A virtual network has virtual devices and links, and therefore it forms a topology graph within. A virtual device is comprised of virtual ports, where a virtual port is realized by a port from the underlying network. And so, as a result of this, a virtual device then becomes a slice and splice of the underlying network devices. And one important aspect here is about virtual devices and links specifically. They're elastic entities in a sense that they're not backed by a specific path or paths. For example, you don't prescribe a link as in terms of this specific path. Rather, you just simply specify a link like you would normally say it connects this port and this port.
But at some point it has to be backed by.
Yes. Oh, absolutely. Oh, absolutely. It's just not that it's not something that is part of the definition.
Okay.
Okay. So some of the basics of operation here is because the virtual network has topology, applications then can traverse the topology graph. They can find their own paths through the topology and so forth. The topology events pertaining to the virtual network itself are triggered by SCC, strongly connected cluster changes in the underlying network, which means if you disconnect, if you don't have any potential of connectivity, then either the virtual link or virtual device is marked as down. But as long as potential connectivity exists, it's all good.
Okay.
Because the virtual network has no inherent connectivity, this implies that no actions really need to be taken during the definition or creation of the network. We can simply say, I want to create a virtual network as this device, which comprises of these ports, and this device comprises these ports, and they're connected with these devices, and that's it. You actually don't need to take any action on it at this point in time because there's no implied connectivity. So actions on the underlying networks don't need to take place until after the virtual network has actually been programmed to do something. So any logical tunnels don't need to be created until they're actually needed for connectivity. Okay.
Okay. Okay.
All right.
The representation of the virtual network must change if the underlying physical network is segmented for some reason.
Yes. Yes. Exactly.
So is there a status associated with these links? Like when you create a virtual link, you said you don't make any changes to the underlying network, right?
Yeah.
So how do you know that when you do want to use that link, it is possible to create an underlying path?
As long as there is any a possible path.
Okay.
So the existence of a path does not necessarily imply that you can use a link.
Use it, right?
But presumably there's some way of sort of periodically probing the underlying topology to see if it's possible to get.
So for example, if all the paths require you to make some reservation, bandwidth reservation,
Yep.
You need to
Make
a reservation, upfront, right? So that can only be done if you do it upfront.
Well, so the thing is, the link. The link could theoretically exist.
No, but the thing is that like once you create your virtual network, right, and you define the topology of that network, that mapping that you've created has to be realized somewhere in the data plane at some point. I would argue that it has to happen when at the creation time, because that's when you know all the resources that you need. At that point in time, that's when you need resources. What if I create my virtual network, some other guy that already has a virtual network increases his resource usage, I can no longer be satisfied, but I've already been told that I have this virtual network, right? So now what do? I get into this big, long, battle between things. But if you just reserve, and it simplifies what we found when we built OVX.
Is that doing your reservations up front is
it's easier, and also mapping traffic into these kind of like pseudo tunnels, so pseudo wires, becomes like trivial.
Yeah.
Right.
So the downside potentially is that you're going to have if you have a lot of pairs, like all pairs points in your virtual network, you potentially are going to over provision where there may not need to be connectivity. For example, a big switch.
Yeah. So that we provided mechanisms around that, right? So you could, when you created a big switch, right? The implied connectivity of the big switch was that all ports were connected. There was a full mesh inside the big switch, which was not seen by the user, obviously. But what we also suggested was that you could actually say, the user could say what connectivities, what port pairs were allowed to be connected, and you could imagine a third approach where like you dynamically do that. Because within a big switch, within a big switch, you can hide a lot of things and do whatever the heck you want, right? But the assumption becomes then that like everybody else is running a big switch as well, because if people are using part of your big switch for their virtual network, then things get very, very complicated very, very quickly. You need network embedding and stuff to make sure you keep things separate and in the right place, and it becomes a nightmare. So my suggestion would be start with a simple case, right? Create your virtual network upfront, right? And then program it upfront onto the data plane, creating reservations with the understanding that like that's less suboptimal, obviously, right? But it's also with the understanding that like there's an operator that operates this network, and this operator knows what he's doing to his network and should not want to destroy his network, right? And
then potentially
optimize that later.
Optimize it in the future.
So in OVX, what we said, we punted on that problem completely. We just said there's a network embedder somewhere. We'll ask the network embedder, and the network embedder will magically return to us with a close to optimal solution that we can deploy, right? But that problem is already solved by other people who are strong mathematicians and not us, or not me, rather. Well, I like math, but not that much.
Yeah, so it looks like there's definitely a proposal of, what Thomas is proposing is lazy allocation, and what Ali is proposing is
Proactive.
sort of proactive allocation. And from my perspective, when you request resources from an operating system, it can either tell you the truth and say, I'm giving you these resources, or it can lie to you and say, I'm giving you these resources, and then when you try to use them, it may or may not work. And I like the former approach a lot.
Well sometimes like virtual memory, right?
Virtual memory is a little bit like the latter
It lies to you. It says, here's 4 gigs or 6
Yeah.
gigs or whatever you want.
So-
And it doesn't allocate pages of physical memory.
I mean, I agree. You're right.
I mean, address spaces do that, right?
Yeah. So
Both approaches maybe are valid, but I tend to like the former.
So, and again, in OVX, we took the virtual memory approach for one part, right? For address virtualization, right? We told you have all the IP addresses in the world. You can do whatever the hell you want, which is true until you ask for too much. Right? And then all of a sudden the system would say barf and say like no more, right? But basically we would like the person, because we would have a cake and we'd create a bunch of smaller cakes, right? But all the cakes look the same as the first one, just a little bit smaller, and such that you probably wouldn't notice, right? But of course, I mean, something's got to give somewhere, right? Like at some point, something's got to give, right?
Yep.
Yeah, I was just saying that traditionally operating systems have taken one of the two perspectives, and one of the two approaches, and perhaps different ones are useful, but we might want to consider the proactive approach for people who actually need a resource allocation guarantee.
But it's kind of an implementation detail.
In a way,
Right.
it can be. So depending on what technology and what method you choose to program your virtual network, it can be more or less apparent that you have this problem.
But it also changes the semantics in an important way.
Well, you can hide a lot of that, right? You can. I mean, if you take Nicira style virtualization, right? You can still expose topologies. You can still do a lot of reservation. You can still program your virtual network. It's just that your virtual network instance is only programmable. Your virtual network instance is only programmable at the edges, right? From the perspective of the user, that's the same thing. At the end of the day, it's the same thing, because he can program his virtual network at these edges, right, and get the same behavior that he wanted. But you're hiding it completely from him. That's fine. These two approaches are completely fine.
So they can both exist at the same time. So for example, if I have an application which requires stronger guarantees, then I create a virtual network, make sure it is strongly partitioned, meaning the resources are allocated upfront. But if I have an application, which can run when,
to be reliable.
like for example, I'm running like a backend process, which shares resources with a bunch of other processes, then as a whole I allocate like a chunk of resource statically, but within that I allocate as things show up.
That's possible. Maybe that's feasible. Yeah, it's maybe feasible. I'd like to try that out, because it's what you're saying is I have a virtual network, I've provisioned into the network, and then some other virtual network that comes and goes essentially.
Yeah.
And that virtual network
or your demand comes and goes.
Yeah, the demand comes and goes, or like something that like wants to use that virtual network comes and goes essentially, right?
Yes.
And so
it depends on like what you're willing to give up to get that, right? Are you willing to give up that? Like sometimes it just won't work, right? Sometimes
Yes.
like the other virtual network.
So you're either going to block other people from doing work because your reservations are going to prevent them from making networks, or you're going to say sometimes when I want to use this, I'm going to be blocked because I can't get the resources.
You can't. I think that those two are like mutually exclusive.
So I mean, the alternative is, you know, if I have
you can, but then
10
you
such
will.
applications, instead of giving like, you know, static 1/10 to everyone, I have the potential of actually getting the full slice, but I also have the potential of getting nothing.
So I would argue that that's an optimization on the basic OVX model, because that's like the more you do that kind of stuff, where you allocate resources directly to a particular tenant, you're entering the realm of like para-virtualization, where you pin resources to a particular tenant of the system, right? Which is fine. It's completely acceptable. That's what we do with all this stuff in there. We pin CPUs to a VM, and it's pinned to that VM. No one else is using it, right? But I would argue that is something that you layer on after you have the basic model, not in the same, not all in the same place. Not as like, I would argue that the basic model provides the virtualization, provides the mechanism, and then on top of that you can add higher level abstractions of your virtual network or extra features and extensions. Like I mean, like you might want to provide virtualization extensions to your guest operating systems as well. There's a lot of things you can start doing, and once you start doing this, you can do snapshotting, migration, whatever you want. Right? That's where it gets really fun, but that's later.
So with respect to the motivation for this basic operation here, for deferring any action until the time of programming, the rationale for that was to essentially stay away from the issue of managing a potentially large number of logical tunnels and constructs like that. Especially if you wanted to produce SDN networks, which don't necessarily have a full mesh connectivity, then doing the preemptive tunnels might be inefficient use of the existing resources, might be too greedy. There was a rationale.
Yeah, I think that's it's completely dependent on your virtualization, what you use to implement your virtualization. If you're really going to create point-to-point tunnels, like really going to create point-to-point tunnels, then I agree with you. But if you're not, and you're just mapping traffic into a new arbitrary header, and then you can just go ahead and do that because you're not consuming any resources that you weren't going to consume anyway.
Right. Yep. But okay, noted. So as it turns out, actually, currently we're programming the connectivity as the current approach that we're taking right now is at sort of a transitive stage. Is we actually programming the connectivity at the time of definition. But the long-term goal was to accomplish this. So we can still discuss exactly, how we want to approach that for long term. So because it's a subsystem currently, we do have a couple of services associated with it. First of all, we have a virtual network service, which is read-only service for being able to list the tenants, list the networks, list the devices, links, and hosts on the network, and similarly for ports. And using this, you get actually the virtual entities. You get the virtual device, virtual link, virtual port, and so forth. Of course, from this service, you can also get these narrow-down ONOS services, which are services that today's applications expect and can find using the OSGI injection. So you can get things like a device service, host service, link service, topology service, path service, intent service, and so forth. You can't get necessarily all of them, but you can get the ones which relate to the topology and which relate to the programming. And what you will get using this method is you will get a service which looks just like the regular ONOS service, except it has been narrowed to operate only in the confines of the given virtual network, which means you can't see outside of it. And the entities that are returned by these services or that are manipulated by these services are the regular ONOS entities. So this can, of course, be accomplished only if the virtual counterparts are extensions of the actual object. So, for example, virtual device extends device. And I will show you a UML diagram later down the line. So the virtual network service is something that applications will be using to operate on the virtual networks which have been defined. Now, how do you define the virtual networks themselves and their structure? You use the virtual network admin service. Through here, you are able to register and unregister tenants, or really just the tenant IDs. You can create and remove networks for tenants. You can create and remove devices, links, and stuff like that on a network. Basically, this is where you build a topology, and you can then create or remove ports on the device. And this is, you can essentially have an elastic notion of a device, which endpoints it offers. So these two services provide ability to manipulate the virtual network inventory and to be able to query. Now, how is the interaction with a southbound accomplished? So since we're not, let's say, since we don't necessarily want to build dependency on OpenFlow. So currently, it's envisioned, and this is the approach that's currently being verified by Brian and Claudine Zhu from Siena, who are helping to work us on a proof of concept virtual network provider. The virtual network provider essentially allows us to interact with the environment to make the necessary logical tunnels happen for link traversal as well as for device backplane traversal. And the idea here is that this provider will set up the tunnels on demand. Now, today, it actually does it in response to the virtual network structural changes. But in future, as I mentioned, the idea is to do it only on demand in response to programming edicts. And the idea here is that the virtual network provider then maintains the tunnels in face of various network failures. So that means device and link failures are absorbed as long as the provider can cope with them somehow. Okay, and this can pertain not only to connectivity itself, but also potentially to congestion or oversubscription of certain resources. And the idea here is that the virtual network provider, if it detects some irrecoverable errors or network outages, it can report events to the provider service, and these will be reflected as essentially, device or link failures. So, is there any questions on this part?
Remember error 32.
Yeah, we got another error 32. So
I can hear you fine still.
Yeah, I know, but we got one in the middle of when you were talking, and so I think we'll just agree on this one for now.
So you sure don't need to repeat it? Okay.
I mean, did you say anything contentious in there? Because the slide to me doesn't look that contentious.
I've never said anything. No, I'm just kidding. Only the stuff that's on the slide. I didn't say anything else.
All right, sounds good.
Okay, all right. And so, okay, we visited this already, essentially as part of the detour on the other slide. So we probably don't need to dwell on this one too much because we've rehashed it, right? So there's one specific area about port sharing. Clearly, because we want to allow virtual ports to be, virtual port is realized by an underlying infrastructure port. And because virtual networks must be able to share ports, there has to be some way of differentiating the traffic that passes through. And so to share interior ports, I think that's fairly simple. Basically, the pass-through traffic must be tunneled or encapsulated or tagged somehow, right? And that's a responsibility of the virtual provider to be able to do that.
It can also be sliced.
Sure, yes.
I think is actually the best way to share exterior ports.
Like flow space slicing?
Yeah, flow space slicing.
Okay.
Also, it depends what you're.
I mean, which admittedly is a superset of tagging. Just saying.
Yeah, exactly. So, but I mean, the thing is that like it also depends what your unit of virtualization is. Is your unit of virtualization the people participating in the virtual network, or the infrastructure element that you're using to virtualize? So what I mean by that is your exterior port. Is that your unit of virtualization, or is it the guy dangling out the exterior port? Right?
Well, so the exterior port, now, of course, what is an exterior edge port, right? It's basically where your VMs would, or your hosts would attach.
Sure. So that, I would argue that like that you don't want to virtualize that port, right? You want to virtualize what goes into that port. You see, it's kind of goes along the lines of what Bob was saying. It's kind of it's flow space slicing, but a simplified flow space slicing.
Yeah, well, the thing about flow space splicing, I think it's the right way to think about it, because you can either say, well, this virtual port is owned entirely by this virtual network, in which case anything going in it goes in that virtual network. Or you could say, well, actually it's on a legacy Ethernet switch, legacy bridge, and so this VLAN goes into this network, and this VLAN goes into the other network. Or you could say, well, actually, maybe it's different laptops connect, and depending on what IP address they go to different addresses.
That's what I'm saying. You don't virtualize the actual port.
Yes.
The data going, the traffic going into that port, and so that's the flow space slicing part.
I would say the port is virtualized also because it exists as a virtual port in both virtual networks.
But that's implicit.
Yeah.
Yes. No, and so in my view, clearly we must allow sharing of interior ports, but whether or not we want to allow sharing exterior ports, you can either you can basically say, this edge port belongs only to one, can belong only to one virtual network. That's one approach we can take, or we allow some sort of a tagging or flow, basically slicing.
Yeah, I would argue it's a useful feature. I would argue that it's all a subset of flow space slicing, and that other alternatives are useful.
Okay, so that means the answer to the first question that I had is basically yes, we should allow it.
Potentially, yeah.
Yes.
Immediately. Yeah.
And another question I have, whether we need to support is sort of like a remote virtual edge link, meaning that the actual host has to traverse some part of the network before it gets to the edge. Do we want to allow that even?
What do you mean by that?
So you want to allow connectivity from a host? Well, this is kind of like flow space virtualization, Thomas.
Can you explain the question? I don't get it.
Which is basically the VM does not, your virtual network is composed so that its virtual edge is actually not directly connected to where the host resides on the underlying network.
All right. So that is you can definitely do that.
Why?
No, you can start by doing that, right? Like if you want your, usually technically there's very limited scenarios where this happens, because when somebody builds a virtual network and they have a host that's in that virtual network, they're going to create a virtual switch that embodies, if not as a big switch or as a single switch, the mapping to the physical switch that's connected directly to that end user. So in most cases, this is a no. It's a moot point. In some cases, you might want to support a link, like a virtual edge link, a virtual edge link to the first virtual switch, but it's not really. It's not a scenario that is very common, I would say.
Yeah, I think the answer is yes, yes, but maybe it's not hugely important. But things like host mobility, where you want maybe your host to move around in your physical network but still be attached to the same port in your virtual network. That sounds like a very useful thing.
Yeah, I mean you can always do that, right? Like, I mean it's a virtual element.
Yeah. So whether you do that via virtual link or via reattaching the port is sort of.
It's a virtual switch, right? So
yeah.
Once you move, if you move the physical port underlying it, then it's not a big deal. That's easy. I would say that there's another consideration to have is how do you handle external connectivity from a virtual network, right? So that particular virtual network wants to talk out to the internet, say, for example.
Yes.
Right. That is a harder
problem to solve. And OVX had a solution for that, which we used, which was, I mean, I can talk about it right now.
Virtual gateway, right?
Yeah, we had a virtual. It was basically we had a virtual network, right? That was a special virtual network. It was called Tom0, just for all intents, just because it sounded cool. And basically what we did in that virtual network is that virtual network was a gigantic switch, right? And for every gateway that you created in each other virtual network, that big switch got a virtual port. That virtual port routed you out to the internet. So it was the responsibility of the virtual network to deliver traffic to that port, and then the Tom0 would take that traffic back out to the internet.
Yeah, so I guess there's a really important point here, which is that having devices that act as gateways between virtual networks and also from virtual networks to your LAN or to the internet is an important thing to solve once you have these virtual networks.
Right. So that's another question. But that can be tackled later with the constructs. My claim is that you can build this support
With the other primitives.
with the primitives of the virtual network.
Yeah, I believe so too. Like Mininet has the same problem, which is that Mininet's a network virtualization system that creates virtual networks that have no connectivity to the internet. So how do you connect them to the internet? Well, the answer is I create a NAT element which is connected to the internet on one side, and then I attach the virtual network on the other side.
Right.
Attach potentially multiple virtual networks can be attached either to separate NAT elements or to basically create a virtual network. And what Ali said is exactly right. That they're created. These gateway elements are created using the same primitives that the rest of the network virtualization uses.
Yeah. Sounds good.
Okay. Thank you. That's a good point. So we touched on this is a point I promised I would talk about a little bit later on when I was discussing this particular approach. So when it comes to virtual networks and applications, the idea here is that the on-platform applications, they can be tenant aware, but they cannot be tenant specific due to the limitations that I described earlier. And the idea here is that the tenant-aware applications could be programmed to do different things. They're basically aware of the different tenants and could be doing different types of things based on policies to different types of networks. But the idea here is that only one instance of each such application exists on behalf of all tenants. And it either acts on behalf of that tenant or it doesn't, but it's just tenant-aware. And the idea here is that the tenant-specific apps would not really adequately scale in the way we treat applications in ONOS today, both due to the symmetric nature of deployment, which assumes that the application runs everywhere in the cluster, as well as there will be some, even if we did overcome that issue, there's still going to be the issue of how do we properly track and isolate the use of compute and memory resources. Within OS GI, there's really not that great a way of going about it.
Yeah, I just have something to say, which is that your complaints about on-platform apps, like those are just complaints in general about the ONOS apps. So it's those are problems that it would be really nice to solve anyway, right? But particularly compute, memory, and resource isolation. That was when people first proposed using Java for ONOS. My first question was like, well, how are you going to do memory and compute resource isolation between multiple applications? And at the time, Amesh was like, well, yeah, IBM has a JVM that can do it, so we can use that maybe. But there still hasn't been a good answer to that question. And that was one of my big questions of like, well, if we can't solve this, we really should not use Java or the JVM because it's an important problem to solve. Or we should rethink our architecture to have multiple JVMs, communicating through shared memory segments.
Well, and that's that. So the limitations that you mentioned is really nothing necessarily specific to OSGI. You're right. It's completely it's Java really. And even though Java does have some policies which you can prescribe, which will limit certain a certain code running on behalf of certain principle to certain things. It's really mostly just for security benefits, and the sandboxing works really, really well. It's not nearly as advanced as modern process level isolation is at currently. So we never really.
And arguably,
That's a really original goal to achieve such isolation for on-platform apps, which is why we didn't really blink an eye to use Java and ONOS GI. The idea here is that if you wanted to accomplish that, you can always use off-platform applications like we suggested in the last one, as separate processes or even running completely separate different machines.
Yeah.
And this is where you can sort of do microservices.
Yeah, to follow up on that, there's currently off-platform applications are really second-class citizens because they don't have a high-performance way of interacting with the ONOS kernel, and perhaps things like gRPC and shared memory, and we can come up with some better mechanisms to support separate processes for separate applications.
Agreed. Yes, completely agreed. But the idea here is that using something like microservices or some other mechanism basically deal with potentially large pieces of code, potentially even lambdas, right? To do tenant-specific processing, but still to interact with the network using the ONOS cluster.
There's also this interesting thing about on-platform versus off-platform. At the end of the day, you have a finite set of computing resources in your data center, and so they're going to need to run somewhere. So if you say, oh, we can't run it in the JVM because we don't have enough resources on our server, well, putting it outside the JVM running on the same server is not going to help you. Like, oh, we'll just create another VM running on this server, and that'll reduce it
somewhere else.
Yeah, well, no, but assuming you have, it's a zero-sum game, you have a finite set of hardware. Yeah. So, in some sense, on-platform or off-platform is just a shell game. You're robbing Peter to pay Paul. Creating a new VM does not miraculously create new resources.
Yeah, yes and no. So I completely agree with a finite amount of resources. My point here is not really to try to avoid that, because clearly it's a closed system. They're just finite resources.
Yeah,
My point was more to highlight the level of isolation that you can accomplish between one application and another application. Plus also, both in terms of access to data as well as compute and memory type resources, or even I/O.
Yeah, I think you put Monan said the same thing. That the point is to prevent a buggy or misbehaving application from eating up all the resources of the system and grinding into a halt.
Correct.
It can also be choose to run them on the same machine. For example, you can have better performance than sort of arbitrarily deploying it in any available location. So there are trade-offs.
Yes. But I think you're absolutely right, Bob, in the sense that we're lacking a high-performance channel to be able to interact with, with nearly full granularity with the ONOS APIs. We currently don't have that. REST APIs are certainly, a good starting point, but it's a poor man's approach, really, for this particular sort of deployment pattern. Okay. Now, of course, using the today, but it's something using REST API is something that can be accomplished today. The idea is that the tenants could use the various REST APIs and interact only with their networks. Now, of course, this is also still predicated on be able to have some scoped authorization scheme where we basically saying, because right now we have a sort of a single scope, which is once you authenticate, you're authorized to do everything. Clearly that's not going to fly long term. I mean, you need to be able to we need to be able to authorize people to operate on different parts of the model, depending on their credentials.
Yeah, so going back to the idea of providing an open flow northbound, an open flow northbound would provide a kind of higher performance sort of RTT scale, way that client applications could potentially interact with their networks. Of course, they would probably be running on another instance of another controller. But that's something else to think about too.
Yes. But as was mentioned earlier, that could be built as an app, right?
Yep.
So where are we today? So the basic interfaces and the basic implementations of the model and some of the manager stuff was actually coded in Drake. But then the work suspended because we were busy doing other stuff, and the work resumed in Falcon, and this was with help from Sienna. So Brian Stanky and Claudine Chu from Ottawa helped us implement the distributed store, the CLI, REST API, and are now currently working on a proof of concept virtual network provider, which is using intents on the underlay to basically to provide tunnels. And the whole idea of this exercise is to use it as a vehicle to verify the nascent core provider interruptions. Because at the time of Drake, we only scoped the virtual network provider side. The virtual network provider service was empty. And so that's something that's being done right now. Now, all of this code is in incubator, and it's marked as beta. And it's still work in progress.
So,
No, go ahead.
I thought you were done, but you're not, so carry on.
Well, so I was just going to say, this is just a UML diagram obtained from IntelliJ. And here, just a few points of interest here. You can see that, all of the virtual elements are extensions of their counterparts, both in terms of the interfaces and their default implementations. So they tie into the overall core model.
So if I boot up an ONOS app and it gets a virtual network, just to clarify, basically I can use the same APIs and I don't have to worry about whether it's a virtual network or a physical.
No, exactly right. No, not exactly.
Well, yeah.
It should be that way. If it's not, why not?
No, well, you have to specify a tenant ID.
Okay, suppose I register as a tenant. From that point on, I mean, I haven't written any ONOS applications. I don't really know how you bootstrap yourself in ONOS, but presumably, you get, a network graph, and you get a virtual network, which is a set of objects that you can call methods on, right? So presumably, that API is symmetric between virtual networks and physical networks.
Yeah, I guess so.
So what's different? Can I clarify?
Yeah.
What's different is how you obtain references on the services. So today, applications, when they need to use a topology service, they specify in their component, they specify an auto wiring annotation, and they'll be given the topology service. Now, applications that want to operate on virtual networks, they have to get a topology service for this virtual network. And once they have it, from that point onward, it's the same.
Yeah, so basically, I guess what you're saying is that, there's sort of bootstrapping code where you get, a set of services, and instead of using the default services as your root objects or whatever, you just say you request a set of, you request the virtual service for a tenant ID. Is that correct?
For a virtual network. Not for a tenant ID, for a virtual network.
And how do you get that virtual network?
Well, so tenant can have multiple virtual networks. You need to know which one you want.
I see. Okay.
So it's basically like change root.
Yeah,
right?
yeah.
Once you've done that, then from that point onward, everything should be the same.
So basically, I don't have to rewrite my code. Like an irritating problem, for example, with Java is that whenever you add a new field to an API, then you have to change all the things that call it because they're default arguments. So for example, you can imagine, suppose we added a permissions argument, and now I have to change all my code. And now I add in a virtual network argument, now I have to change all my code. Now every call takes a tenant ID. That'd be like a bad approach, right?
Yeah, that's exactly what we wanted to avoid. Absolutely. Yes.
I would
So I like this approach, and if possible, I'd like to be involved in the implementation and future work of this.
Great.
But sorry.
No, that's great.
Yeah, absolutely. I'd like to do some of that. The only thing I would say, and I realize it's like a big sweeping change, not of this, but like of ONOS, would be to make virtualization a first-class citizen rather than just another yet another subsystem.
Right.
I realize that's like it's a tall order, and it's a rather big change, but in my opinion, that would be the optimal approach.
I think it's a good idea to sort of think out that approach and like sketch out what it would look like and why that would be and what its advantages would be.
Well, the advantage is kind of like simple, right? Like from the get-go, everything is virtual, right? Anything, even if you have only one network and one tenant, it's still a virtual network. It just so happens to be isomorphic with the first one, with the original one. And then if you want to add other virtual networks, you can do that naturally because it's the base of the system.
But so that almost describes to me that you're basically calling for introduction of a user space. Because what we really have right now, really, if you think about it, with ONOS, is just the core, the kernel.
Yeah.
Right? And with this, you would basically saying, okay, what we have now is the kernel, and nothing else goes in it unless we, control it. And then we will introduce user space basically through the notion of this overlaid.
Yeah, so maybe we should probably sit down and discuss this, but I think you're seeing the virtualization layer above the core. I'm seeing it under the core. Maybe we should sit down and discuss this in more detail on a whiteboard or something.
And hopefully, like, present your conclusions too.
Yeah, we can do that.
Yeah.
No, I guess I was seeing it as the boundary between user space and kernel space.
Right. Okay. Yeah. Again, I think we should just because it's hard to get this. It's hard to like. I see what you're saying, but I don't know what that actually means in terms of like a.
I see. Yeah.
So it's probably easier to just sit on a whiteboard and see that and discuss that.
Right.
I gotta go though.
One thing to keep in mind is that there is a difference between sort of abstractions and virtualization. For example, in operating systems, we have we have virtual disks, but they also abstract the disk as a file system. So both are actually useful, and what you use depends on your application. But I think the same thing will apply to us as well.
Right.
The CPU is virtualized as processes, but we also have virtual CPUs. Or abstracted, I guess, as processes.
Right. No, I agree, Ali, that it would be a sweeping change, but I think this is something that we may, as ONOS evolves, we should definitely keep an eye on it. Probably, clearly not immediately, but we should definitely consider it.
Yeah, but I definitely want to be involved in the design and implementation work of this.
I think it's a really good idea to have the people who worked on OVX collaborate on it, because I think a meeting of minds and many heads will be better than one.
Yeah.
Well, that would be perfect. So, like I said, we already have a code for.
No, I know. I mean, we worked on the APIs together. Now you have some implementation. I'll have a look at the implementation.
Yeah, I was gonna say that. If you don't mind looking at the existing implementation, now keep in mind that the virtual manager and the virtual network provider that's currently being worked on by Brian, that will evolve because right now it's the connectivity is the logical tunnels are set up, torn down as the definition of the virtual network changes.
Okay.
It's actually a legit approach in my opinion. So think about it.
Anyway, I got to run. I have another.
Okay. Well, I think that this is pretty much all I had then. It was a good discussion. A lot of good suggestions and questions.
The one caution I have is to not become overly married to a prototype implementation. I think getting the design right is really important. I mean, what I can say from all my experience in like working on virtual systems for many years is that getting the design right is really important, and it's worth putting some careful thought and effort into it.
Agreed. So again, Bob, if you also want to put your eyes on that existing code and both interfaces as well as some of the implementations, your feedback would be greatly welcome.
Great.
All right, everyone. Thanks a lot. I'm sure there will be more news on this, and I definitely look forward to having your help. Talk to you later.
Bye.
Bye.